So previously you learned about the KiCad Project Manager, and now I'm going to give you a tour of the individual applications of the KiCad software suite. As you may recall from the previous lecture, you can access the KiCad applications from the main Project Manager's right pane, right here, or via the Tools drop-down menu. Let's start with the Schematic Editor, and as you can see here, I've already loaded a project. This is one of the projects from the book. It's an MCU data logger or microcontroller unit data logger. It's one of the projects I said I'll be using this project to demonstrate the various KiCad applications. So let's start with the Schematic Editor. So here is the Schematic Editor. You can use the Schematic Editor to draw the schematic of the PCB. Although KiCad is flexible enough and allows you to create PCBs without the schematic, this is really a good idea. The schematic diagram captures all necessary information that the layout editor uses. The components, such as these resistors or this integrated circuit symbol, these are also wires, and the wires can look like actual green wires in this case, or we can also use names such as this label here, which is an alternative way to connect pins together. Instead of using a wire, we use names. So whenever you have pins that are connected to the same name, such as SCK here and SCK here, these are actually logically and electrically connected to each other. There's just another thing you can do with the Schematic Editor. You also have things such as buses, power nets, such as this ground power net here, and much more. So this is where you begin a new PCB project in KiCad. You always start with the Schematic Editor, and that's what we'll be doing as well. So in this example, you can see a schematic, as I said, from one of the projects. There are symbols like U1, U2, U3, and U4. There's the wires, the pins, etc.
Just a short interruption to let you know that this video is part of my comprehensive KiCad course that will teach you every aspect of creating printed circuit boards with KiCad from scratch. Go to the course page to learn more about it if you want. Find the link to the course page in the description below and treat yourself with a discount coupon for my YouTube viewers. Okay, let's continue with the video.
All right, so you're going to be spending a lot of time with the Schematic Editor, but that's enough for now. Let's continue with the PCB Editor. To get to the PCB Editor, you can click on this green button here. Notice that the icon is just a smaller version of the PCB Editor button in the main data logger window. So just for this example, I'm just going to close the Schematic Editor and enter the PCB Editor through the main KiCad window. And that's what it looks like. I can click on this button right here to, actually this one here, to focus and zoom into the PCB. So in this example, you see the PCB version of the schematic that we were looking at earlier. So the process is that once you finish with the schematic, you import the data of the schematic into the PCB editor and you start physically laying them on the canvas to the actual positions where the PCB will have things such as pads and holes and vias in the final PCB, and then do the wiring. The layout editor allows you to select things such as the layer that you want to work on. So for example, if I want to do wiring on the front copper layer, I select it from the Appearance Layers menu, and then I start drawing using the pen tool or the track tool. Start creating tracks. Of course, this is going to be interfering with existing work. You can see that the PCB editor is highlighting any collisions or any conflicts with a bright green color. All right, I'm just going to undo a couple of times to remove what I've just added. There's a lot of tools here that allow you to create what you see here. Again, don't worry, this is a bit early to go into the details, but this is just an overview. All the tools that are available to you, I'll be explaining a little bit later, also as part of the projects that are coming up. So for now, it's just sit back and relax and see what is possible. One of the most interesting features, at least for me, is the 3D viewer. because this allows me to get a feel of what my PCB eventually is going to look like, but it also allows me to spot any errors, any mistakes, for example, in the silkscreen labels or positioning of components that might not be good, appropriately positioned, especially any components that allow for input and output, like the position of the headers here. Those sometimes are easier to see for issues and find solutions when you're looking at the 3D representation of the PCB. Okay, let's close the PCB editor. I'll discard any changes, also close the schematic editor, and let's continue with the symbol editor. The symbol editor allows you to modify existing symbols or create new ones. For most projects, you'll be able to find the symbol that you're looking for, but that's always the case. Eventually, you'll need to either modify an existing symbol or create a new one from scratch. And that's what the purpose of this tool is. It allows you to both edit existing symbols and modify them and save them as a new version of the symbol, or create symbols from scratch. I'm going to show you how to do both. So that is the symbol editor. Let's come out of that, and you probably are not surprised to know that there's a tool to allow you to edit existing footprints or create new footprints from scratch. Okay, so here is the footprint editor. The footprint editor resembles really the PCB editor. You can see that it's got the same number of tools and types of tools on the right side, but on the left side, it gives you access to the library. So you can pick a footprint and make changes to it as you see fit. Or again, as I said, you can create a new one. Another really nice feature of the footprint editor is that it has a wizard. So with the wizard, I'll just discard. So with the wizard, you can use a footprint generator. You can select a generator for a number of existing types of footprints. Let's say, for example, a QFN package. And then you can use the parameters for this particular type of footprint and quickly create a customized type of that particular footprint. I've got a dedicated lecture again later on in this course in the recipes section to show you how to use the footprint wizard. So let's come out of the wizard and then out of the footprint editor. I'll discard the changes and let's continue with the Gerber viewer. In a previous lecture, I gave you a sneak preview of what the Gerber viewer looks like, but I'll show you again an example. So let's go into, for example, the Gerbers for the 4-layer PCB. This PCB, I created 2 different versions, a 2-layer and a 4-layer. And that's what it looks like in the Gerber viewer. So the Gerber viewer allows you to inspect the PCB before you upload it for manufacturing, and that allows you to detect any potential problems that you didn't pick up earlier in the process, or that the schematic and PCB editor checkers didn't detect. So the Gerber viewer is a sort of a quality control tool. There are other tools that you can use as well, which I also recommend, and I'll be talking about later on as we go through the projects. Okay, let's come out of the Gerber viewer. After that, we've got the image converter. So the image converter allows you to take in, for example, a bitmap image, such as, in my case, it's the logo. See if I can load it. Which looks like this, and then convert it into a footprint. I've got a lecture to show you how to do that. You can convert it into a footprint or as graphics for the PCB layer so that you can use it for the purposes of decorating, in this example, your PCB. So if I go back to the 3D viewer and flip this example back, you'll see that I've got logo here, which started its life as a bitmap image, and then I processed it through the image converter into a footprint so that I can use it for this particular purpose. So I'll show you how to use the image converter to create custom footprints from an original image. Next, we have the calculator tools. So there's a bunch of tools here that allow you to do calculations, as the name suggests. So, for example, there is a track width calculator. It allows you to insert things such as the value that you expect or you want a particular track to be able to accommodate, and you tell it how long it's going to be. And in real time, it calculates the width and the thickness that is required. So for example, let's make the double. You can see that the calculation happens in real time. Let's double that as well. There you go. Aside from the track width calculator, there's a bunch of other calculators. It's a good idea to browse them. There's instructions to explain how they work. But specifically about the track width calculator, I have a relevant lecture in the recipes part of this course that you can have a look at how it works and how you can use it in your PCB designs. Next up is the drawing sheet editor. So with the drawing sheet editor, you can change the size of the schematic sheet and everything within it. So all parts of the schematic sheet, such as in this case, the variables, the lines that you see here, where they go, the size of the entire sheet, everything here is configurable. I have a dedicated lecture on this topic as well. So if you want to create custom sheets, have a look at that lecture. And finally, there is the plugin and content manager. It's a very important part of the KiCad toolset because it allows you to extend the functionality of KiCad by installing and activating external plugins. You can see in this example, I have already installed a selection of plugins such as free routing. This is a plugin that allows automatic routing of a board. I have a lecture to show how to use it. There's also DFM. So this is a plugin from Next PCB. DFM stands for Design for Manufacturing, and that extends the quality assurance tools that are built into KiCad, especially the various checkers with additional set of checks and controls that Next PCB does via this plugin. So I've got a lecture that shows how to use this. You can see there's another 10 specifically designed oriented risk issues that this plugin can detect. It can also tell you where those issues are and how to fix them. There's an interactive HTML BOM or Bill of Materials plugin that I'm showing you how to use as well in one of the recipes in this course, and lots of other plugins are available. If you browse the official repository or third-party repositories, then you can see there is an increasing wealth of plugins with very interesting features that you can experiment with and you can tap on and use in your projects. I have a dedicated lecture later on in this course to show you exactly how to use the plugin and content manager.